Hello friends, in today's session we're gonna learn how to create a 3D parametric model of plastic screw boss attachment by using CATIA V5. Now, designing a screw boss is pretty straightforward, but there are some considerations like manufacturability of the attachment, stiffness of the attachment to hold the parts at a desired load, and also you have to consider how to mitigate some injection molding defects like a sink mark which is not acceptable in the appearance or visual surfaces of the part. For example, automotive interior parts like a door panel, instrument panel, etc. Now, let's create a new part. To create a new part, go to this menu bar and select the file and select the new from this flyout. A new window will appear on the screen. Select the document type part and click OK. Now another new window will appear on the screen. Rename your part screw boss and check this create a geometrical set and click OK. Now new part is created. In that you can find 3 absolute planes, 1 empty geometrical set and 1 part body. The geometrical set and part bodies works as a folder which is used to organize specific type of data. Geometrical sets exclusively used to organize wireframe and surfaces data, while part bodies or bodies are used to organize solid features. But if you are using hybrid design, then part bodies or bodies can also organize wireframe, surface, and solid features together inside it. We are creating a screw boss for M6 screw. We're going to build our screw boss model such a way that we can easily position and orient screw boss anywhere in the part, and also quickly modify the screw boss for a different size of screws and tooling conditions. Let's create some basic prerequisite reference elements. First, we create a point which represents the position of our screw boss. So in the point, select the point type by the coordinates and put here 0, 0, 0 for XYZ and click OK. Now we create a second element, that is direction, which represents the direction of a screw. So for that, select the line and select the line type, point and direction. Select this point and direction, right click inside this box and select Z component. Change the end point and start point and click OK. Now right click on this geometrical set, go to properties and go to this feature properties and change name to inputs. Right click on this point, go to properties and change name to start point. Also go to graphic and under points change the color to yellow and symbol to star. Right click on this line, go to properties, change the name, draw direction, and in graphic under line and curves change the color to pink, line type 4, thickness 3. Select these two elements, right click, go to the selected object and isolate. Now hide these three basic elements. Create new geometrical set and rename that screw boss construction. Now select Make sure that this is working defined. If not, right click on it and define in work object. So this geometrical set, you can see the underline under the name. Now select the plane which is normal to this line passing to this point. Right click on it, rename, go to properties and rename mating part interface. Properties and change mating part interface. Now create a point on this plane. Select origin start point or reference point start point. Make H0, V20 and click OK. Now create a line passing through these 2 points. Select first point, second point and click OK. Now we create a new line which represents the orientation of our screw boss. So for that, change the line type to angle normal to curve. Select the curve first, then point and then support. The new line is created at 45 degree with this given line. Change that to 0 and click OK. Now hide these two elements. Right click on this line 3, go to properties and change the name to feature orientation. Now we'll create a plane passing through these two lines. So go to this plane type, change here through two lines. Select first line, second line and click OK. Now we create a line which represents the lifter slide direction. So here line type should be angle normal to curve. Select the curve, select the start point and select the plane. Here angle should be 1. Click OK. Right click on this, go to properties and change name to lifter slide direction. And go to graphic properties. Under lines, color change to yellow, line type 4, thickness 3. Hide these two elements, feature orientation and plane 2. Now we'll create a new plane which represents the lower limit of our feature or screw boss. So go to properties and change the name here, lower limit. Create one more plane on the upper side, which is 2.5 offset. Right click on it and name as sum of mating part thickness. Click OK. Create one more plane from this sum of mating part thickness in opposite direction. Make here 0.5 and click OK. Rename that to payload. Hide this. Now let's create a screw boss. For that, insert a new body. Go to this insert, select body, new body is created. Rename that, go to properties and rename that the screw boss. Click OK. So before create a sketch for the screw boss, let's open one table. So in this table, you can find the inner diameter of this boss for self-tapping screws. Look at M6 at standard metric thread. The inner diameter is 5 mm. Now close this table. And what about the outer diameter? So as per design guideline rules, the outer diameter of the screw bar should be 1.5 to 2 times of the screw diameter. So here we'll consider a 1.5 times and we'll calculate the screw outer diameter. So first go to this position sketch, select this support as mating part interface, select this origin as a projection point and select the start point and orientation parallel to the line, select this, lift the slide direction. Now select this circle and create a circle at the center. Give the dimension to diameter 6. Now we create the outer diameter here, which is 1.5 times of this M6. So what we can do, click on this and click this FX. Now you can add formula and select this D and you can add here formula into 1.5. Click OK. So whenever you change this dimension like M8, this outer diameter also changes. Make this M6 and as per table our inner diameter is 5. Now select this 6 mm diameter circle and convert that into construction. Exit from the sketch. Now you are in GST workbench. We should be into the part workbench. So now change the workbench to the part workbench to create a solid model. So now we are in the part workbench. Make sure that your screw boss is defined and your sketch is underneath of the screw boss. Then select this pad, select the sketch, and here in the type, select upper plane and select this preload plane. Click on this more. Under the type, select up to the plane and select this lower limit plane. Now the cylinder is created for the screw box, but now we are going to add a draft. So adding a draft is very important design consideration, which helps to eject the part easily from the mold without damaging the features, also the appearance surfaces. So as per design guidelines, all the vertical faces to the die direction should have at least minimum 0.5 degree draft. So we'll select this vertical face in die direction and also select this another face. Now select the neutral plane as this preload and pulling direction is a diagonal direction. Here make a 0.5 degree draft and make sure that dimension is such a way that you are adding the material on this outer surface. One draft is added on this inner and outer surface. We'll select this chamfer and select this inner diameter. Make here 0.5 and click OK. So now screw boss is created. Now we'll add one more body for the ribs. So why we need ribs? Rib increase the stiffness of the screw boss and also it provides the resting face for the mating part. But the number of ribs varies depending on like space available or the flat space available on the mating part. So what we'll do, we'll create a rib by using sketch. So make sure that rib is defined. Go to this position sketch. Select this mating part interface plane. Select the projection point and select the start point. Select orientation parallel to line and select this. Click the direction and click OK. Now we'll turn on this sketch and we'll create one more sketch, circle sketch around it. Now I can directly give the constraint with respect to diameter, but I'll convert that into reference and I'll give the dimension between this and this. So I'll keep here 18. So maybe I can just change that to, it's a 9, 4.5. Convert that into construction. Now select the line from center to this and give the dimensions between this line and this one. So 90 degrees. So by using this value you can orient the sketch wherever or the revolve position wherever you want. Now exit from the sketch and use this pad. We get this error window because your sketch is not closed. So open. Click on S and click here thick. Now change the direction in the opposite direction. Go to this type and select here lower plane. Now in this thin pad thickness is 1, but you can see the thickness is added only one side of this profile. So I need the same thickness on the both sides. So when I click here neutral fiber, you can see the profile become at the middle and you have 0.5 on this side, 0.5 on this side. Now we'll add a draft on these faces with respect to this. Select this mating surface and try the directions correct. Now we'll add one more draft. Select the same. We are giving here the separate draft triangle, so that's why we have created a separate draft at 5. Now give here radius 1.5. Update. Now we'll create a pattern. Select here reference element as and direction, and in parameter select complete crown and here add the number of ribs, 4. Now insert a new body and rename that body screw boss with ribs. Make sure that this body is defined. Now add a screw boss into that body. Screw boss is added in this body. Now right click on this ribs and go to this rib object and select here union rib. And here in the remove, you have to select the face of this pad, not the circular pattern. So select here face from this pad and click OK. So why we need to select that face? Because this is varying. If you change, suppose if I want this 3 ribs only, so if we change this 3, 1 rib is vanishing. So in this case also it's working properly. So change it to 4 and update. Now hide the sketch, meeting plane and the preload plane. So this is our screw boss with the ribs. Here you can't see any undercut. You might get a question why we are using this lift a slide direction. Let me explain. In the most of the plastic part, we use the self-tapping screws. That needs a screw boss walls to be thick. It might be a 2 mm or thicker than that. This will cause a sink marks on the apparent surfaces of the part, as shown in these pictures. Now let's understand why the sink mark appears and is there any solution to get rid of this. So sink mark is an injection molding defect which is caused by uneven cooling of the part during the manufacturing. And whenever you create any feature like a screw boss or ribs or any snaps, so whenever you create any feature on the nominal wall of the plastic part, it increases the thickness at the junction or at the root of the feature and it causes the sink mark. Let's understand in detail. To understand this, we'll open one image. So in this image, there are 2 ribs, one with this thick root, another is the thin root. In the above image, it's a thick root. We'll discuss about the thick root first. When the part cools, the large amount of core region at the junction remains hot for the long time. Then eventually it cools down and shrinks and pull the skin inward and cause the big sink mark. In the lower image, you can see the root thickness is thin and comparatively a small amount of core region remains hotter, and also the comparatively small sink mark will be appear on the screen. So there are some solutions to overcome these issues. You can core out some material at the root of the features as shown in these images. There is another solution. You can reduce the root thickness of features than 50% of the nominal part thickness, which also helps you to reduce the sink mark on the part. But if you do that in the case of the screw boss, It affects the stiffness of this part. So reducing the wall thickness at the root, it doesn't work for this. So what we should do for this? So there is one more solution we can do. We can create a doghouse which will take care of this root thickness, and we can also keep this boss thickness thicker without compromising any stiffness. Now let's create a doghouse. For that, insert a new body. Rename that. Go to properties. Rename that doghouse body. And we'll define this screwbox construction. Create offset from this meeting point interface in this reverse direction at 12. So now this defines the height of screwbox above the doghouse. So right click on this and just rename this screwbox height. Now select this position sketch, select this plane, go to origin, select the projection point and select here start point. In the orientation, select parallel to line and select lift the slide direction. Now click OK. Now here select centered rectangle and click on this horizontal line and create the rectangle. Now we're going to give the dimension from this vertical to the center of the center rectangle. Make that 1. And now we'll show the main sketch of the screw box and we'll give the dimension with respect to that. So for that, select the sketch, outer edge and select this and make this 6. The same way, select this outer edge and select this horizontal face and make it 6.5. Exit from the sketch, pad. Now this is giving the warning because my body is not defined and sketch is also created in this screw box because my doghouse body is not defined. So cancel that, cancel this, right click on it, work in define, right click on this and change the geometrical set and select this body, define, select a pad, select the sketch in the reverse direction and here up to plane, select this lower limit. Now we'll add a draft to this vertical faces. Select this neutral plane as the screw box height plane and select here draw direction. Preview. Material should be added on the outer side. Click OK. Now we'll add one more draft on the side along the lifter slide direction. Select this neutral plane as this face and the pulling direction, select this lifter slide direction. Change the direction and here put 3. Material is removing. Click OK. Now add one more draft on the top surface with respect to this face. Select neutral face and lifter direction should be a 1 degree. Now select your fillet on this back edges, give weight and give this radius 2.5. Now create a new body. Go to properties and change name to doghouse. And copy this body and paste special with result with the link. So it creates a linked body here. So whenever I change something in this body also update. So hide this body for now. Define the doghouse working object. Right click on this doghouse body and add that into the doghouse. Now apply a shell on this doghouse body and make this inside thickness 2. Now hide this doghouse body and we'll now work on this covering body. So before that we have to create one more plane. So define working object and create a plane offset from this screw boss height in this reverse direction at 8. We can say covering. Change the name of this body, covering body. Work and define this object. Select this plate. Select this covering plane and change the direction. The above portion will split, that is unwanted portion. Now we'll add a draft on this top face with respect to this face in the that direction. In the lifter slide direction. Now we'll apply a thickness on this outer wall and that reduce the wall by 1 mm. Now I'll add here a radius of 2 and this is our covering body. Now show the doghouse and work in different doghouse. Right click on this covering body and remove from the doghouse. Select the sharp edge and give this to 3. Now you can see this root thickness is 1 and the top thickness is 2, and this root thickness is maintained throughout the doghouse. Now create a new body. Go to its properties and name as screw boss with doghouse. Now add a screw boss into the screw boss with the doghouse, and then right click on the doghouse and go to doghouse object and union trim. Here in the remove, select this inner surface and click OK. Update this screw boss with the doghouse. Hide this lower plane. Hide this screw boss height, covering plane, and also the sketch. Now click this and change the graphical properties. Go to and change the color of this feature. And this is our screw boss with the doghouse. Now let's modify the location and the orientation of the screw boss. So we created a lot of reference element. Now we'll see how we can use this reference elements to modify our geometry quickly. So for that, open a mating parts, copy this mating part 1, mg geometrical set, and mating part 2, copy, go to the screw boss and space special, the result. This file contains the attachment point and the direction. So we'll change here color to yellow and this color to blue, yellow. So now we'll change the first position. To change the position, right click on this and click on the replace and select this attachment point and click OK. Now update the screw boss. Now you can see the location of our screw boss is changed. But one problem is there. We selected here the direction. So you can see this rib is not updated till yet. So for that, right click on this direction and replace. Select this direction, make sure that the angle is correct and click OK. Update this. Now you can see the screw boss is updated. Given location. Now we have one more mating part and we need to modify the screw boss accordingly. So what you can do, you can go to this summation of this mating part thickness. Let's measure the distance of this. It's 5.5. So change that to 5.5. Double click on it, make this 5.5 and update. This will automatically update your screw boss with respect to number of mating parts when you change this value. Now hide these values. Now we'll check if we change the orientation whether it updates or not. So for that, just click on this feature orientation and change the angle. Change the angle and update. Now we'll see when you update the lifter direction how it updates. So suppose there is like a undercut here, you change the lifter angle and now update this Now you can see this face is updated along with the selected direction. Change it to 1. Update. Now we'll modify the number of ribs. So our part is such a way that there is no enough space for the 4 ribs. So we'll just change this to 3 ribs. And update our part. So it updates quickly. Now last thing is we're gonna modify our screw boss for M8. So center upon this, we modify the sketch to 8, and for this inner diameter we'll open a table. So in the table for M8 the inner diameter is 6.8. Change this to 6.8 and exit. Now update a screw boss. Now you can see the whole screw boss is updated, the size is increased accordingly. This is the end of our session. Thanks for watching.